well. Okay? Maybe you'll get 12 points, not deducted. I mean, you get 12, assuming the algebra's done right. Are you with me? Okay? So that's why it's so important to show your work on my test, because I do believe in partial credit. You see, just because a student under the pressure used a 2 there does not mean that they're out to lunch. Okay? They can get everything else right and still get a substantial amount of credit, in my opinion. All right? Are we doing good? Okay, you ready to do lab? Yeah? Who's excited about this lab? Anybody? Well, what does a calorimeter do? Well, a calorimeter is something that is really insulated, and it is a way to measure how much heat, how much energy is in something. Now, an example that you guys can put your fingers on. There's a type of calorimeter called a bomb calorimeter. All right. When I was teaching PChem lab at Auburn, we run these bomb calorimeters all the time. Here's what you do. It is a stainless steel piece of metal. Okay. And inside that stainless steel piece of metal, there's a little bitty shelf right there. Well, guess what you can put on that shelf? You can put anything you want to, like an M&M. Okay? So you put an M&M on that little shelf. And then what you do is you take yourself a wire and touch that M&M with it. You have to be sure that the wire is touching the M&M. Okay? And then what you do is you put and you screw it on. Right? It's a big stainless steel thing. So you have to screw down the lid. Right? This is a bomb calorimeter. So the next thing you're going to do is you're going to pump in this thing pure oxygen, somewhere around 40 atmospheres, thus the bomb effect. All right. Now, do you think 40 atmospheres of pressure is a big pressure or not a big pressure? What do you think? That's a pretty good amount of pressure. All right. 40 atmospheres is the same thing as 588 pounds per square inch. That's huge. All right. So what's the point of doing that? To ensure that whatever's in there will burn. Okay? Whatever's in there is going to burn. So then what you do is you take and you submerge this whole apparatus into a tub of water. Okay? So this whole thing here now is wet. Are you following? Okay. Then you are going to hook up electricity to this, right, and hope that you don't get shocked. So you're going to hook a positive in here and a negative in here. And then there's a red button on the table. There's going to be a thermometer here. Now this right here is a thermometer, or a thermocouple. So you sit there and you push the red button. It sends a shot of electricity through that wire. What's going to happen? It's going to burn. The wire's going to burn. The M&M's going to burn. Everything in there is going to burn. What will happen to this stainless steel? Will the temperature go up or go down? Go up. And then you can use what? You can use these same equations here to find out how much the temperature goes up and what can you relate it to? Joules. Okay? So, let's just say here that something releases some item, 582.1 joules. How many calories is that? So get to the back of your textbook and find me the conversion between joules and calories. One calorie equals 4.184 joules. Alright, so that means that this is going to be 1391.3 calories. And you may say, my God, man, how much food are you burning? This is a lowercase c. What's on the back of your M&Ms? is a capital C. There are 1,000 calories in 1 kilocalorie. So how many kilocalories is that M&M? .3913 kilocalories per M&M. All right. So when you read on the back and it says serving size around 15, well, what does that mean? Well, it means if you eat 15 M&Ms, then you're going to get, 17 or 18 calories, whatever it happens to be, right? And I'm just being silly. I'm making up numbers. Who knows what it is? So what's the point? Well, the point is there's numerous types of calorimeters that can use the notion of changing temperatures to get to caloric needs, to get to calories, and so forth, right? So if that interests you, there are chemists that do nothing but stand there and find out these caloric intakes, right? Anybody that reads the back of these food labels, you think, oh my goodness. Does anyone ever look at serving sizes? Mm-hmm. Who the hell follows that? Really? You buy a bag of potato chips or something like that, and it says, there's 27 servings in here, right? Or whatever. And you're thinking, you're not going to eat those things 27 times. So, same way with a can of Coke, right? There's like 2 servings in a can of Coke. Who's going to drink a Coke? Stop that. I mean, that's just silly. All right, so what's the point of the lab today? Okay, here's the point of the lab today. We got water here in our calorimeter. All right. We got a metal here, but we do not know what the metal is. So can we find out what the metal is using a thing of boiling water? Okay, so that's the idea. So let's go ahead and get up our chart here. We're going to have mass of the metal, specific heat of the metal, final temperature of the metal, and initial temperature of the metal. Okay, mass of the water, specific heat of the water, final temperature of the water, initial temperature of the water. Well, what do I know up to this point? Well, I know the specific heat of water is 4.184. The specific heat of the metal, I do not know what that is. That's the point of the lab. Because in theory, what we should be able to do, right, but experiments go wrong, so if something goes wrong, that's good too. We should be able to look here in this table and be able to pick out a metal that we got back there. All right. So, is everybody happy with what we're doing? Yes, no, maybe? Yes? All right, who's going to be my writer? Who would like to be my writer? Would you like to be my writer? I saw your hands first. You be my writer. Can you be my writer? All right. So this is mass of the metal, 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 right? So there we go. So you can just fill in this table as I read it to you. And as far as the camera goes, you can go back and forth. Not all the time, okay? Just at your will. Okay, so the first thing we're going to do, right, is put on the safety glasses. And that's always the first thing we're going to do. Now, I'll look up there, and what's your first name again? Brittany. Brittany. Okay, Brittany's sitting there, and she's saying, read to me the mass of the metal. Well, how am I going to do that? Well, I'm going to take the mass of this piece of metal here. We do not know what it is, and I'm going to walk over here, and I'm going to give it to her. 28.96, Brittany. And that's going to be in grams. So this little demo here, the idea is we can maybe figure out what the mass of this metal is. Okay. The next thing is the final temperature of the metal. We don't know what that is yet. I've got a thermometer back here. I can measure it later. What's the initial temperature of the metal? Well, I just put that metal into boiling water. What is